Here's the solution to page 350, number 23. It is a very difficult problem, a C problem, and no, you won't have anything like this on your math test except possibly for extra credit. The reason to look over this proof is because it is challenging and it's good practice in finding a needle in a haystack, which is what sometimes you have to do to find the triangles you need. EFGK is a parallelogram. That's going to give us parallelogram angles. And with vertical angles, we're able to set up similar triangles. We have to find similar triangles that use the information we're given, and there's not very much of it. MJ equals 4, JH equals 5. So the question is, which triangles and how many? Since we're being asked to find EM, I looked for pairs of similar triangles that used EM in one of the triangles. And I also looked for pairs of similar triangles that used the numbers that were given. With so little information, I expected that I would have to find more than one pair, and I was looking for triangles that had the same segments in both, because I might have to do a substitution maneuver at the end in order to connect the information from the two different triangles into one answer. Let's see how that works. Because this is an algebra problem, you're not required to say more than the similar triangles that you're using. It's a courtesy to mention the similar triangles so that the person reading your problem will be able to figure out what triangles you're using. I use the blue triangles, and I use the fact that EF was parallel to KJ. There are 3 angles that I have to choose from. I only need 2, and even though I don't have to mention them in an algebraic example, it is nice to know what the corresponding angles are. FEM in the upper blue triangle, congruent to MJK in the lower blue triangle, or KJM as I wrote over there, alternate interior angles. Or you could use EFM on the right, which is alternate interior to MKJ on the left, or you could use the vertical angles. Either way, you have similar triangles, and the corresponding parts give you that EM over 4. EM is corresponding to 4, and X is corresponding to Y. Because of the alternate interior nature of the problem, there's always a twist to the corresponding parts. Over here, I use the red triangles. Again, I chose a triangle that had EM in it and a triangle that used the same segments as the blue triangles used. That's why I called FMX and I called KMY, because I knew I'd be using them more than once. Because these two segments are in the blue triangle and the red triangle, they're going to provide the link we need to get our two ratios for our final solution. 9, which is down here, is corresponding to EM, which is up here. And then X, which is in the big triangle, is corresponding to Y, which is the little triangle. And yes, I got it right this time, kids. So for all of you who went crazy in class because I wrote the problem upside down, I fixed it. Are you proud of me? Because X over Y appears in both problems, I'm now able to connect EM over 4 with 9 over EM. When I cross multiply, I get that EM squared equals 9 times 4 is 36. And when I square root both sides, I get that EM is equal to 6. Algebraically, EM is plus or minus 6, but because this is a geometry problem, I eliminated the negative. Again, you can go to the portal, you can download this video, and you can also download a student copy on which you can put your own solution as long as you mention the similar triangles you're using, mark your diagram, and set up your ratios so it's very clear exactly how the problem works.